Today we're going to talk about some types of factoring that we will use often in Algebra 2 throughout this semester and next semester. The first method that we are going to talk about is greatest common factor. So when you're looking for greatest common factor, you're looking for the largest number by which you can divide all of the coefficients. And then you're going to determine if the terms have any variables in common. And then divide each term by the GCF and make sure that includes the largest number and the common variables. So for this problem is here, I have 10, 40, and negative 45 for my coefficients. I can divide each of those by 5. So I'm going to put my 5 out front. And then I look at my variables, a squared, a, and then I don't have a variable for that last one. So since I do not have a variable in this last term, I cannot take out an a in my GCF. So I'm going to leave my a's alone. To figure out what's left over, we're going to divide. So 10 divided by 5 is 2, still have an a squared there. 40 divided by 5 is 8, still have an a. And 45 divided by 5 is 9, so minus 9. So there's your GCF. Let's go ahead and try 4 more. Okay, this next problem here actually has some variables in common. So first let's look at our coefficients. I have 10 and 20. I can divide each of those by 10. And then notice I have a p squared there, and technically I have a p to the first there. Since they both have p's in common, I'm going to take out the smallest amount. Okay, so p to the first, or p, and then figure out what's left over. So if I do 10 divided by 10, I get 1. Don't usually write it there, but you can. And then if I have 2 p's, but I take 1 p out, I'm left with 1 p. For the second term, negative 20 divided by 10 is negative 2. If I had 1 p there, but I took a p out, there aren't any p's left. Now to check this, which you don't have to show me, but you can still do it in your head, you just need to distribute. So 10p times p is 10p squared. 10p times negative 2 is negative 20p. This is the original problem, so I'm in pretty good shape. So this is just our check step. Okay, next problem, GCF. I can divide 6, 12, and 9 all by 3. And then notice that they all have x's. So I'm going to look for the smallest exponent for my x's. I have a 3, a 4, and a 5, so my smallest is 3. So my GCF is 3x to the third. I'm going to go ahead and divide to figure out what's left over. 6 divided by 3 is 2. I had 3 x's, but I took 3 out, so I don't have any left. For the next term, 12 divided by 3 is 4. I had 4 x's, and I took 3 out, so I have 1 left. And for the last term, 9 divided by 3 is 3, and I had 5 x's, but I took 3 out, so I have 2 left. Okay, again, to check it, all you need to do is distribute. For C, I can divide each of those coefficients by 6, but this last term doesn't have a variable, so I can't have a variable in my GCF. So 6 divided by 6 gives me 1, still have an n squared. Negative 24 divided by 6 is negative 4, still have the n. And then 6 divided by 6 is 1. Do not forget that 1 there. Common thing that students drop off. Last one. Okay, 40, 45, and 10, I can divide each of those by 5. And then since this 10 doesn't have an m, I cannot include a variable there. So 40 divided by 5 is 8. M squared stays. 45 divided by 5 is 9. M stays. And 10 divided by 5 is 2. Okay, again, to check those, you can distribute. So that is factoring out a GCF. Next, in the next video, we will talk about how to factor using the difference of two squares.